Alright, now we're going to start introducing the concept of the determinant. So first, I want to recall what we've done so far with determinants. So if we have a 2 by 2 matrix, A, where we have entries A11, A12, A21, and A22, we previously wrote these as A, B, C, and D. Then we say the determinant of A is equal to A11, A22 minus A12, A21, or AD minus BC. So if you want, with 2 by 2 matrices, you can still use the letters A, B, C, D. It might help to remember which ones you're multiplying by. However, when we get to bigger matrices, these are going to be a problem. But for now, let's find the determinant of the matrix 3, 5, 1, 2. So to do the determinant, normally we'll just do straight lines. So we would write this as the straight line 3, 5, 1, 2. And this stands for the determinant of the matrix 3, 5, 1, 2. So this is equal to A11, A22, so this will be 3 times 2, minus A12, A21, so that's minus 5 times 1, so this is going to be 6 minus 5, which is equal to 1. So the determinant of this matrix is equal to 1. And because that's not equal to 0, we know this matrix is invertible. So again, we did show that before. If the determinant is not equal to 0, then the matrix is invertible. Okay, so let's go bigger. Let's go A to n by n, where n is greater or equal to 2. So then we say that the determinant is the sum of n terms of the form plus or minus a1j, capital A1j, and these pluses and minuses are going to alternate. So first, let's talk about what this a1j is. So aij is the submatrix formed by deleting the ith row and the jth column. So, for instance, let's say we have A11, A12, A13. I'm going to fill in all these entries here. So this would be, that would be 3, 2. And A12, A13. So a matrix. So that's A. So then let's say A23. So to form A23, what we do is we remove the second row and we remove the third column. So then in our matrix, we're left with A11, A12, A13, and A32. So in our final column, our second entry is, well, that's our column that we're getting rid of. So we're never going to get A something 3 in our last column. And we're getting rid of the second row, so we're never going to have a row that starts with the entry 2. Okay, so that's how we do things here with our submatrices. So, with that being said, the full definition of the determinant, if I write it out here, is going to be A11 determinant of A11 minus A12 determinant of A12, and we'll go all the way up to -1 to the 1 plus n, A1n determinant 1n. So again, we have to go plus or minus between all of these. So this sign is going to be dependent on -1 to the power of 1 plus n. Our first one is positive, which means for every even term, for every second term, it has to be negative. Okay, so we can also write this as the sum. So in proofs, you might see the sum being used. Don't be scared of the sum, just remember the general idea of it. So you're taking your terms and then you subtract every other term. Okay, so let's do that. Let's compute the determinant of 135211342. Okay, so we want to start out, and I'm going to do this very formally here. So I'm going to label everything. So what's the formula for the determinant? So the determinant of A is going to equal A11 times the determinant of capital A11 minus A12 times the determinant of capital A12 plus A13 times the determinant of A13. So let's start putting in some values here. So the determinant of A is going to be, well, A11 is 1 times the determinant of A11. So this one is done by taking out the first column of A and the first row of A. So then we're going to be left with 1, 1, 4, 2. Okay, so that's a11. Then we have to subtract a12, which is 3, times the determinant of capital A12, so that's taking out the first row and the second column. Oh, sorry. That would be the first row and the second column. So we're going to be left with 2, 1, 3, 2. And finally, we have to add a13, which is 5, times the determinant of capital A13. So that's going to take out the first row and the third column, so we're left with 2, 1, 3, 4. So at this point, we're down to the 2 by 2 case, so we know how to take the determinant of that. So we're going to get 1 times, well, remember it's AD minus BC, or the diagonal entries minus the diagonal entries, so it's going to be 1 times 2 minus 1 times 4. We're going to subtract, and the determinant of the second one here is going to be 2 times 2 minus 1 times 3. And we're going to add 5 times the determinant of the third matrix, so this is going to be 2 times 4 minus 1 times 3. Put these all together, we get negative 2 minus 3 plus 20, so our determinant is going to be equal to 20. Okay, so this is a recursive definition because we take 3 by 3s, 4 by 4s, 5 by 5s, and we reduce them until we get down to 2 by 2s, which we can then solve numerically. So if I ever give you a 4 by 4 determinant, it is going to take quite a bit of time, so I probably won't do that. So let's just do one more example here. I figure, one example probably isn't good enough, so let's do 2. And let's do it with some negatives, so that way we can get ourselves confused with the adding and subtraction signs. So I'm not going to do this as formally this time. So we're going to say, okay, this is A11, capital A11, minus A12, capital A12, plus A13, capital A13. I have no reason to write the determinant symbol now, because if I'm using capital A's, I probably know what I'm doing. So roughly that. So let's start. Well, it's going to be 5 times the submatrix A11. So at this point, I could physically cross these out to help myself, but really what I'm doing is I'm thinking, okay, so here's the 5, so everything to the right of it I'm going to ignore and everything below it. So that's what I'm thinking in this case. So I'm just going to write the remaining 3, negative 5, negative 4, 7 here. And then we're going to subtract A12, which is negative 2, times the submatrix. So again, I take a look at this 2. I think, okay, everything below it and everything to the left and right, just ignore it. Okay, so I'll do that. Then we're left with 0, negative 5, 2, and 7. I'm going to add A13, which is 4, times, of course, the matrix ignoring the first row and the third column, so we're left with 0, 3, 2, negative 4. Okay, so now these are going to be a little bit more complicated, just with arithmetic. So 5, and here for our determinant, we're going to have 21 minus negative 4 times negative 5 is 20, so 21 minus 20. We're going to subtract negative 2 times, well, 0 times 7 is 0. 2 minus 5 is negative 10, so we're going to subtract negative 10. Then we're going to add 4 times, well, 0 times negative 4 is 0, minus 2 times 3 is 6. Okay, so this is going to be 5 times 1, which is just equal to 5. We're then going to subtract, okay, so we have negative 2 times 10. That's negative 20. So we're going to subtract negative 20, so we're going to add 20. And then we're going to add 4 times negative 6, which is negative 24. So our determinant is going to be 1. Okay, so there's a few things you need to watch out for. You need to make sure that your negative signs and positive signs are alternating. So that's why when I put this in, this negative 2, I left it in as is. I didn't do anything. I didn't quickly change this to a positive 2, because if I do make an error and I need to figure out where I made the error, it might be difficult to see where this came from and if I did make an error at this stage. The next thing Same thing here. I probably should have simplified these first before doing the subtraction and addition, but I'm trusting myself. And then finally, these numbers sometimes can get tricky, but nicely enough, it came out nice to 1. So you can get a number that's a determinant like 240 in some cases. So if the number's crazy, don't feel bad. The determinants and the matrices given were probably just crazy to begin with. So that's computing determinants. Next time we'll talk about cofactor expansion, and it'll make 4x4 matrices a lot easier. So if you have any questions, leave them below, and I'll answer them the best that I can.